Hello. Today I am going to start a new chapter which is quadratic equations. Quadratic equation is one of the most important chapter in our syllabus. Before starting quadratic equations, I would like to recall some terms of the previous chapters polynomials. In the chapter of polynomials, we studied about polynomials and different types of polynomials. So let us first recall what is polynomial. Polynomials is simply an algebraic expression, an algebraic expression fx is equal to a0 plus a1x plus a2x square plus dot dot an xn, where a0, a1, a2 dot dot an belongs to R, and all indices of x, all indices of x are non-negative integers, are called polynomials, are called polynomials. So what is polynomial? Clearly written on the whiteboard. An algebraic expression fx is equal to a0 plus a1x plus a2x square plus dot dot an xn, where a0, a1, a2, an belongs to R, and all indices of x are non-negative integers. Belongs to R means real numbers, and non-negative integers are 0 to 0, 1, 2 up to infinity. So if an expression having all the indices of x non-negative integers and coefficients are belongs to real number, then this is simply called polynomials, or we also call it polynomial with real coefficients, because in the 11th class we also study about polynomial with complex coefficient. So here at this stage we have only deal with the real coefficients, so polynomial with real coefficient. For example, x plus x square plus 1, it is clearly a polynomial, because here x, coefficient of x is 1, x square is 1, and if you take 2 or something, x plus root 2x square plus 1 is polynomial, because index of x are 1, 2, or if it is constant, then simply it means 1 into x power 0. So it is clearly a polynomial. But if we write as x plus 1 upon root x, or simply x plus root x, this is clearly not polynomial, because if we expand it x plus x, it is root x, so it is x power raised to the power 1 by 2, or it is x to the power raised to 1 minus 1 by 2. So if we have index of x non-negative integers, which is clearly here 1 upon 2 is not an integer, here minus 1 upon 2 is not integer, so it is not a polynomial. In that chapter we deal with all examples, and we study also about types of polynomial. And before we study degree of polynomials, degree of polynomials is what? Degree of polynomials is the highest coefficient, the highest power of x, the highest power of variable, simpली हम कह सकते हैं the highest power of x or the highest power of variable is called degree of power of variable, is called degree of variable. Suppose if it is written as fx is equal to x cube plus x square plus 2, clearly here it is a polynomial. First we have to check whether the given expression is polynomial or not. So if we are going to check this, then clearly x, coefficient of x is real number, coefficient of x square is real number, index of x is 3, which is clearly a non-negative integer, index of x is 2, which is clearly a non-negative integer, and here it is 2, which means 2x raised to power 0, which is clearly a non-negative integer. So clearly it is a polynomial. And if we find to degree of this polynomial, then we have to find which is the highest power of the variable, simply which is the highest power of x. Then in this expression we clearly see that the power highest power is 3. So the degree of this expression is degree of this polynomial is 3. So on the basis of degree of polynomial, on basis of degree and on basis of degree and on basis of numbers of terms, we classified polynomials into different types. And here we recall on the basis of degree. On the basis of degree, we, if the degree is 1, the polynomial is called linear polynomial. If the degree is 2, the polynomial is called quadratic polynomial. So I want to clarify that quadratic polynomial is simply what? Quadratic polynomial is simply an expression with highest power 2, ax square plus bx plus c. Clearly it is a polynomial. If we write ABC belongs to R, then clearly it is polynomial with real coefficient, and it is called quadratic polynomial because the highest power here it is 2. So our chapter is quadratic equation. So before coming to the quadratic equation, I clearly explain you what is quadratic polynomial. Now we move to further quadratic polynomials to quadratic equation. Now the quadratic equation, the story begins of quadratic equation from where? When a quadratic polynomial, when a quadratic polynomial, when a quadratic polynomial fx is equal to ax square plus bx plus c is equated to, is equated to, is equated to 0. If we equated it to 0, then it becomes a quadratic equation. Then it becomes a quadratic equation. Then it becomes a quadratic equation. Simply we use Q, capital QE in the short form, which is clearly the abbreviated as quadratic polynomial, quadratic equation. Now it is not mandatory to equate the quadratic polynomial to 0. We can equate it to any constant, any constant. We can equate to it to the any linear polynomial, any linear polynomial. We can equate it to the any quadratic polynomial. We can equate to the any quadratic polynomial. But we have to show that ax square plus bx plus c, if we equate it to any constant, suppose 5, it becomes a quadratic equation. Or if we equate it to the root 2, it becomes a quadratic equation, no issue. But if we equate it to the any linear polynomial, suppose x plus 1, it also becomes a quadratic equation. But in the case of quadratic polynomial, if we equate it to the any quadratic polynomial, suppose bx square plus cx plus d. All right. But here in this case, we make sure that the coefficient of x square is not same. We make sure that coefficient of x square coefficient is not same, because if we equate quadratic polynomial to any quadratic polynomial whose coefficient is same, suppose ax square plus bx plus c is equated to ax square plus dx plus e, then coefficient if same, then it becomes cancel and it becomes a linear equation. So in case of a quadratic polynomial equated to quadratic polynomial, make sure that coefficient of x square is different. So one way we explain that quadratic polynomial, what is quadratic polynomial? Quadratic polynomial is a polynomial of degree 2. And what is quadratic equation? Quadratic equations means any quadratic polynomial equated to 0, or equated to any constant term, or equated to any linear polynomial or quadratic polynomial. But in the case of quadratic polynomial, make sure that the coefficient of x square is different. Then we find a quadratic equation. Now let us move to the next topic. And uh, first I want to recall you this is a quadratic equation. X square plus 2x plus 1 is equal to 0, because here x is ax square plus bx plus c. General form of quadratic equation is ax square plus bx plus c is equal to 0. Again, this is also a quadratic equation, because here ax square plus bx plus c is equal to 0. In this case, it is also a quadratic equation. So here we find that in a quadratic equation, b is equal to 0 does not have any problem in a quadratic equation. Now again, ax square plus bx is equal to 0. It is again a quadratic equation. So here we see that if c is equal to 0, it does not affect on any quadratic equation. But if a is equal to 0, if a is equal to 0, then it becomes bx plus c is equal to 0, which is linear polynomial. So in case of quadratic equation, we should understand that ax square plus bx plus c is equal to 0. A mandatory, it is mandatory that a not equal to 0. It is mandatory. If a becomes 0, then it becomes linear. And a a is equal to 0, a not equal to 0, a is equal to 0, not possible. A is not equal to 0, b is equal to 0, possible. A not equal to 0, c is equal to 0, possible. A not equal to 0, a is equal to a not equal to 0, b is equal to, c is equal to 0, then it is also possible. X square is equal to 0. It is also a quadratic equation having roots plus minus 0. Okay, now again we move that. Now we move to the roots of the polynomial. The roots of the polynomial. What is the roots of the polynomial? Roots of the roots. Okay. First, I want to explain you the difference between equation and identity. Difference between equation and identity. Here is the term equation and identity. I want to clear your difference between equation and identity. Equation is something having no solution or no solution or some solution. No solution or some solution. No solution or some solution. But in case of identity, something equation is x square minus 4 is equal to 0. It is clearly a equation. It is clearly a equation because it is satisfied by two values of x. Root x is equal to minus 1. It is clearly a equation because it has no solution. It is equation. In case of identity, identity is what x plus 3 to the raised to the power 2 is equal to x square plus 9 plus 6x. It is identity because it is satisfied for every x belongs to R. So in case of equation, we say that equation has some solution or no solution, but in case of identity, uh, we have infinite solution. We have identity is satisfied for every x belongs to real number. It is satisfied for every value of x. So it is a difference between equation and identity. And one thing I should clear, if it is written as equation ax square plus bx plus c is equal to 3x square plus 7x plus 5. If it is equation, if it is written as equation, then we can compare here coefficients. A is equal to 3, b is equal to 7, c is equal to 5. But oh, in case of equation, we cannot compare the coefficient. We cannot compare coefficients. But in case of identity, we can, sorry, here in case of identity, if it is identity, ax square plus bx plus c is identity is sometimes written as triple 1, 2, 3, or it is simply written as for every x belongs to R. If it is written as identity, then we can compare directly the coefficient a is equal to 3, b is equal to 7, c is equal to 5. So difference between equation and identity is clear. Now again we move to the next topic, which is roots of the equation. Roots of the equation. Before roots of the equation, I would like to recall the zeros of the polynomial. In polynomials, we studied about if it is written as fx is equal to x square plus 7x plus 12, then we find that value of x the value of x which makes fx vanishes, which makes fx vanishes, or which makes fx is equal to 0, which makes fx is equal to 0 are called zeros. Simply zeros is means are called zeros. Simply the value of x at which fx becomes 0 are called zeros of the polynomial. And in that chapter we also studied it is a quadratic polynomial. Here we find that here at x is equal to -3, x is equal to -4 are two zeros of this quadratic expression. But on the same way we can say that if it is written as x square plus 2x plus 1, here x is equal to -1 is the only value at which this vanishes. So here we find that this expression, quadratic expression, has two zeros. This expression has one zeros, and zeros is always real. When I talked about zero, it means real. Similarly, if we write an expression, quadratic expression fx is equal to x square plus 1, this becomes 0 at no value of x. No real value of x makes fx vanishes. So we say that no zero. So conclusion is that if a quadratic polynomial have at most two zeros. At most two zeros means it has two zero, it has one zero, or it has zero zero. Whether it is has two, whether it is one, whether it is zero, but at most two. But in case of roots of a quad equation, roots of equation is different thing. If we write x square plus 2x plus 7x 12 is equal to 0, the roots of the equation, the value of x, if we take the value of alpha belongs to the value of alpha at which first is satisfied in case of equation. In case of equation it is called alpha is root. Suppose if we put x is equal to -3, yeah, alpha is equal to -3, then we clearly say that alpha is equal to -3 is satisfied. So alpha is -3, -4 is root. But in case of roots of a quadratic equation, we say that exactly two roots, exactly two roots, which may be real or imaginary, which may be real or imaginary. Here in this case, we say that alpha is equal to -3, -4, two roots. Two roots, both are real. But in case of x square plus 2x plus 1 is equal to 0, here x is equal to x plus 1 ka whole square is equal to 0, x is equal to -1 -1. But here the only value of x is -1. But here in case of root, we take it two different roots. X is equal to, we said that x square plus 2x plus 1 is equal to exactly two roots, and both the roots are same. We don't say that it has only one root which is -1. It has two roots and both roots are same. It has two real roots which are different. Same x square plus 1 is equal to 0. It has two, x is equal to plus minus I. It has two different roots and both roots are imaginary. So in case of quadratic equation, the roots always exactly two. They are exactly two roots which may be real or imaginary. And in case of polynomials, zeros are different and roots are different. That is a basic difference of zeros and roots of the polynomial. Or simply we say that if we talk about the polynomials, and we if that it the then it is said it becomes it is called zeros. Or if we call it for the equations, then it becomes roots. And roots are always real or imaginary, but polynomials zeros are always real. So so today's topic is enough. We are again tomorrow for the next video. Thanks.